Okay, welcome back. So we just left off answering B. We talked about the degree of correlation. So we're on to C part. We want to determine the linear equation for this relationship. And I'm going to go back and I'll add in correlation factor here. Strong positive correlation exists because we've got to figure the numeric value. So if I head back here, again, I'm not too worried about the grid lines. Yes, I want a trend and I want the R value. So it has the R value at 0.667. I still got to take the square root, right? Because that's R squared. All right. We want R. R is used for linear. So the square root of 0.667 is 0.82. 0.82. So I'll add that in. R equals 0.82, which still falls in that the strong range there. So C part, they want us to come up with an equation to model this situation. So C part, my equation will be, and like I said, it's just as easy to leave it at this stage to grab it off, because what you're going to find if you hit finalize, sometimes you can't see the entire equation, so I find it just as easy to read it here. 0.53x plus 0.78 y equals 0.53x plus 0.78. There we are, where y represents the wolf population and X represents, and yes, for those that are wondering, it is important and necessary to do this. You need to identify your variables for me. So there we go. So we know we have a strong positive correlation based on our graph. Got all the information I need. I'm just going to hit insert, and there we go. The graph is now available for re-referencing if you want to come back and take a look. Number D, or example D, or sorry, question D. Does the data support the researcher's theory? Now this is where you get to put your thought process into it. So you got to think about the answer in terms of, you know, what's your opinion, and this is what's going to happen for those that do some research or go into fields like wildlife, where you got to make a case for yourself. And in this case, I would say my opinion is yes, the correlation is strong. However, it is not perfect, and in brackets, R is only equal to 0.82. So there might be other factors that should be investigated. Okay, and what that does is gives you future jobs. If you put every answer as there's other factors that should be investigated. So because if it's not above 0.9, you're definitely looking at there's got to be some other factors in there, and you could be looking at weather, food shortage, etc., etc. So I mean, if you want to take it the full distance here, food availability, weather, if it was a harsh winter, on top of influencing the population. So there might be sub-factors within that general area. So, all right. So there's that example taken care of. And we move on to my last one. And I just want to show, this one just shows how greatly an outlier affects your data. Okay, so an outlier, again, is a piece of a data point that does not fall within the trend of the other data. Okay. So the example, a driving instructor tabulates the number of hours of instruction and driver test scores. So that's what that chart is on our right. We want to answer the following. What assumption is the instructor making? All right, so for that first one, they're recording the number of hours and the number of scores. So what assumption is being made here? Well, the first one that should be made is, so assumption, let's say number one, is that more practice improves driving skills. Okay, so a little bit of a sensitive area here. Some people are going to practice and practice, and they're still never going to be great drivers. So the driver instructor is making that assumption that the more hours this person practices, the better driver they will be. And maybe that is something that may come out of it in the future, but it's not necessarily something that's actually going to happen. The next assumption that you could put in there is that all people are equally good at taking tests. Okay. So not everyone, just because you know the information, know the material, you may not score very, very well. So I mean, there's some factors that this person is taking into account. Now, this is the first time we see the term here, B part, analyze the data. So they want us to go through and use our R value. That's basically what that's telling us. So again, I've got that third example prepped and ready to go. So if you go to example 3, highlight the data that we're interested in. We want to insert a chart again, more, scatter, scatter, customize. All right, so hours practicing versus score. And horizontal, on the horizontal we have our hours, and I would like it to start at 0 and go to 30, and vertical, that is our score, and 0 to 100. All right, so that's what the data will look like. So as we go down here, now we're down to trend line. We're working with linear. So we put that in there, the linear, my R squared value. Now when I look at that R squared value, it's 0.144. So my first analysis or point of analysis here, if I go back, so for B, oops, have it show on the screen would be helpful. So for B, the data appears to have a very weak positive correlation where the R value is equal to, so if it's 0.144, remember you got to take that square root, 14, oops, turns out to be 0.37, so not a very good, I mean, it falls into the moderate, but I think it's still a little bit on the weak side. All right, so that's what it looks like at this point. So when I'm looking at the analysis on this, analyzing the data, that's what it is right there. It's talking about the correlation and how strong it is. Okay. Now, if I was to comment on the data, so see it says comment on the data, what I noticed when I graphed it is that these 2 points seem to really stick out, 1015 and 2045. These guys all seem to be kind of clustered together. So I start to ask myself, are these what we would call outliers? Okay. So in my commentary here, I'm going to say there appears to be 2 outliers in the provided data. Now the question becomes, and this is a simple example because there's not enough data here to really remove those outliers and take it to the bank and ask for money to do the research. Really, you should have a lot more than this, but because I just don't want to type out that many data points for you, we're just taking a simple example, and I'm going to say, you know what, these 2 data points, they seem to be outliers. They seem to be away from the bulk or body of the data. So if we remove our outliers, and we go back to our spreadsheet, what I'm going to do is I'm going to remove those outliers. Okay. Now I need to cancel this and start over. So I need to get rid of 1015 and 2045. So I'm going to cancel. I'm just going to delete the 1015 and the 2045, and I will regraph it. So insert chart. More. I'm not going to bother with the headings and titles because you can do that on your own. That looks a little bit better. It's still not very good just because you can see those now seem to kind of fall out a little bit further, but it's not the end of the world. Horizontal again, I'm just going to have it start at 0 and go to 30, and my vertical 0 to 100. All right, now we can go back down. We can try this again and see what happens. And if it doesn't work, then it's just there is no relationship. You kind of accept that. So now it's 0.54, and I got to take the square root of that. So if I take the square root of 0.54, I end up with 0.73. If we remove our outliers, there appears to be a stronger positive correlation in the data, and in brackets r equals 0.73. However, there is not enough data provided. I'm just going to extend this page up a little bit. Provided to justify removing 2 outlying points or outlier points. Okay, just if you come back to this example, I just want to be made note that really, if you only have 7 or 8, removing 2 outliers is pretty significant. So D part here, determine the effect of any outliers. So the outliers in this question affected the correlation factor in a negative manner. The factor improved from 0.37 to 0.73 once they were removed. All right. And that's basically what outliers are going to do. Outliers are going to throw out or affect your overall data results in modeling. The challenging part for you is justifying, can I remove those 2 points? Is that something that seems legitimate? In this case, my argument would be there's not enough data here to support removing them, so I would recommend against that. All right. If you have any questions, let me know, and we can go over it tomorrow. But again, hopefully you're getting a little bit more comfortable with the spreadsheets because lots more spreadsheets to come. All right. Thanks a lot, and we'll talk to you later.